In this video, I'm going to continue simplifying square roots, but I'm going to be using prime factorization. Here's an example of the type of problem that we'll be working on. When I look at the square root of 126, I don't see a perfect square. In a case like that, I need to go back and prime factor the radicand. Here's the prime factorization of 126. I can now replace my radicand with my prime factorization, and within the prime factorization try to find perfect squares. For instance, I notice there's now a 9. I can rewrite the radicand then as a 9 and a 14. The square root of 9 is going to give me a nice perfect square, which will be a 3. The square root of 14 is irrational, and that's the best I can do. I just keep it square root of 14. So my final product is 3 square roots of 14. Notice again how I've used the product property, and if this is confusing to you, you need to go back and watch the first video, which goes over a number of examples that use the product property. Here's one for you to try. Here's the prime factorization of 294. And once I replace the radicand, I notice that there's a 49, 2 factors of 7, and there's also a 6. By the commutative property, I can rearrange the factors, and by the product property, think of it this way, and then square root of 49 is 7. Try this one. Here's my prime factorization, and I notice that there's a 9 and a 15. So I go back and replace my radicand, use the product property, and finish the problem. Here's one that's kind of interesting. Notice that we have a factor of -5 multiplied to the square root of 180. Give this one a try. When I think about prime factoring 180, 18 and 10 come to mind. So I've got a factor of 2 and 5 for my 10, and 2 factors of 3 and 1 of 2 for my 18. And if I put them in order, I notice that I have a factor of 4 and a factor of 9, along with my factor of 5. Rewriting 180 in factored form, and then using the product property, I have the square root of 4 times the square root of 9 times the square root of 5, and the first two give me factors of 2 and 3. And last, I would multiply and find that I have -30 times the square root of 5. Now some of you might have thought, well, but 4 and 9 is 36. Could I have instead just say, I have a factor of 36 and 1 of 5? And that would have been fine. Instead of having two factors, one root 4 and one root 9, you'd have the single factor root 36, and that would simplify to a factor of 6, and once again you'd have -30 square roots of 5. Well, that concludes this video on using prime factorization to help us simplify square roots.